Alright, so here's a quick video recapping what we talked about yesterday and today in class with regards to combining like terms, and then we'll also move into solving one-step equations and inequalities. Now, first off, before we can do anything, I want to just go back to our combining integers unit. And so here at the top I have two combining integers, and so 7 plus a negative 6. And so what I know is that, if I recall from that unit, is adding a negative is the same as just subtracting. So I could rewrite this as 7 minus 6. And then from there I could take it a step further and I could box it up, knowing that that's a positive 7, one symbol and one number, one symbol, one number. So positive 7, negative 6. Now it's just pirates and ninjas. 7 pirates, 6 ninjas. The pirates will win by 1. And so I can have an answer there of positive 1. Similarly, here I have 12 plus 6 plus a negative 3. So I can box that one up. That's a positive 12. Here I have a positive 6. And then plus a negative, as we just talked about over here, is just minus 3. So I could ignore that plus, or if it makes you feel bad, you can get rid of it or just rewrite it without it. Now I have plus 6 plus 12, and so here that's 12 pirates, 6 pirates, and then 3 ninjas. And so here plus 12 and plus 6 gives me a plus 18, and then I have 3 ninjas. So 18 pirates, 3 ninjas, and so my pirates will win by 15. And so that's going to be my answer of positive 15. All right, now that we've revisited that, we can apply the same thing using variables. And in this instance, we're using x and with different coefficients. 5 examples. The first one, opposite x plus 2x plus 4 plus negative 3. So if you want to, we can box all of that up. Opposite x and then a positive 2x. So that's, I could say that's a ninja x and 2 pirate x's. That's going to give me net of a positive x. And so you could write, if you wanted to, positive 1x or just 1x. But if I don't write that and I just write x, I do know my coefficient is 1 because this is 1x. All right, so we have x and then positive 4, negative 3. And so that's going to be 4 pirates, 3 ninjas. My ninjas will lose that one, so pirates by 1, so positive 1. So x plus 1 for my final answer there. Or my simplified, not really my final answer, but my simplified expression. All right, next one. Opposite x, and then a positive 2x. I have a negative 3 and a positive 1. And so again, you can rewrite it without that plus, or you can ignore that, knowing that it's the same thing. And here's my example of that. All right, so opposite x and positive 2x, that's going to net me a positive 1x. Negative 3, positive 1 is going to give me a negative 2, so x minus 2 as a simplified expression. The third one, negative 3x and negative x, or opposite 3x, opposite x. Positive 4, negative 2. So looking at the x's, combining those like terms, opposite 3x, opposite 1x is going to give me an opposite 4x. Positive 4, negative 2. My pirates will win that one. That's going to be a plus 2. So negative 4x plus 2 as my simplified expression. Cruising right along, opposite 2x, opposite x. Positive 3, positive 2. So opposite 2x, opposite x will give me an opposite 3x. Positive 3, positive 2 is a positive 5. So negative 3x plus 5. Simplified expression. Last one. Opposite 2x, positive 2x plus 4 minus 3. So looking at just the x portion, negative 2x, positive 2x, that creates a 0 pair, so that's just nothing. You could write, if you wanted, 0x, but 0 times x is just 0, so there's no reason to write that. +4, -3, the pirates will win by 1, so my simplified expression is just 1. Looking at solving one-step equations and inequalities. Now I have 3 equations because they have the equal sign, and then I have an inequality, and here it's a less than sign. So we'll solve these 4, then I'll show you 4 more. Now the important thing, and this is what we talked about today, is I need to first identify my operation. I need to know what my inverse of that operation is, how I undo that operation, how I can isolate my variable, and then ultimately solve. Now my goal is to solve, and how do I solve? I isolate the variable. So that's where I'm trying to get to. My goal is to solve. I solve by isolating the variable. Before I can isolate it, I need to know what my operation is. I need to know what the inverse is. And so my first example, 8x equals 32. My goal is to solve. I solve by isolating the variable. My variable is x. And what's with x is 8 by which operation? And so it ends up being that is multiplication. This is 8 times x. Well, if my operation is multiplication, my inverse, how I undo multiplication, is with division. So I do need to divide. So here, this is x times 8. And so I undo that by dividing by 8. And so I'm going to set this up on all of mine. All right. So instead of x times 8, I need to divide by 8. But what I do to one side, I have to do to the other. I have to keep it balanced. And so 8 divided by 8 is 1. 1 times x is x. So that leaves me with just x. I can bring down my equal sign. 32 divided by 8 is 4. And so now I have a solution of x equals 4, and I can substitute that in. So I go back to my original equation. 8 times x, which is 4. So 8 times 4 equals 32, and that does check out. That is a correct answer, verified, and I'm good to go. Another example here, 37 equals x plus 28. Now you might be able to do that one just by looking at it, but it's important that we go through the steps. So that way, this just, as the numbers get more difficult, the process is the same. So 37 equals x plus 28. My goal is to solve. I solve by isolating the variable. Variable is x. With my x is a 28 by addition. So my inverse is going to be subtraction. So x plus 28, I undo that by minus 28. So I have to do that to both sides. So what you do to one side, you do to the other. That gives me 0 pairs, leaving x by itself or isolated. So I've isolated my variable. And then 37 minus 28. And so I have 9 as my answer. Now I can check that by substituting it back in. So here I have x. I'm going to substitute 9 back in. So 9 plus 28 is in fact 37, so it does check out. And so there is my solution. And again, I have 9 equals x, and as we talked about in class, that really is the same as x equals 9. So if it gives you heartburn to have the variable on the right side, feel free to rewrite it as x equals 9, and those mean the same thing. Next one, 29.5 equals x over 10. Goal is to solve. I solve by isolating the variable. My variable is x. And with x, I have 10 by way of division. So my fraction bar is division. I undo division, or my inverse of division is multiplication. So I do need to multiply both sides by 10. And I don't really like multiplying fractions by a whole number, so I'm going to make both of those a fraction. And so that way it's just easier. I didn't change anything, that's still 10. I just made it into a fraction so it looks a little bit easier to multiply. Now I can cross cancel my 10s. And so now I have basically x times 1 is x divided by 1. So x divided by 1 is still x. And so by my properties of my operations, I know that I've isolated x. So I've undone or got rid of my divided by 10 by doing the inverse. So x, bring down my equal sign. And now 10 times 29.5 is going to be 295. And then to check my answer, I can substitute that back in. And so I have 295 divided by 10. So I got to move my decimal over, and sure enough, that checks out. That is a good answer. All right, number 4. I have x over 4 is less than 21.5. So now I have an inequality. And what we're going to find is that inequalities are exactly the same as far as how to solve them. Now, graphing them will look a little different, and we'll get into that. But solving them is really the same. And so x over 4, my goal is to solve. I solve by isolating the variable. My variable is x, and it's tied to a 4 by way of division. So I undo that with multiplication. So instead of dividing by 4, I need to multiply by 4. And I'm going to multiply by 4 on both sides. Make that one into a fraction. Cross cancel. That leaves me with x. And now 21.5 multiplied by 4. And that's going to be 86. All right. And then here I just have, just like I did with my equal sign, I'm just going to bring that down. So my less than symbol, and so x is less than 86. And to check it, I'm going to substitute, and I'm just going to set it equal just to check it out. And so 86 divided by 4, sure enough, that is 21.5. So my answer does check out. So x is less than 86. And so not any different for an inequality. Let's look at a couple more. And then we'll end the video there. All right, so I said a couple. We're actually going to do 4 because I want to do a couple that don't play so nice, or a few that don't play so nice in addition to this last nice one. So looking at these here, let's kind of set it up the same way. All right, so what I do to one side, I have to do to the other. So let me make my sides. All right, so x minus 11 is greater than 9. So my goal is to solve. I solve by isolating the variable. Variable is x, and with x I have a minus 11. So I'm going to undo that with plus 11. I have to do that to both sides. 0 pairs x, and then 9 plus 11 is 20, and I'm just going to bring down my symbol. And so x is greater than 20. And I'm going to set it equal and substitute. So 20 minus 11 is 9, so it does check out. And there is my solution. Now let's try one that doesn't play as nice and see what happens. So 99 minus x equals 102. Goal is to solve. I solve by isolating the variable. My variable is x, and with x I have 99. Now, is this a positive 99 or a negative 99? And so when we think about that, it actually is a positive 99. Don't let it fool you that I have this here. That's still a positive 99. I isolate it by subtracting 99, and I need to subtract 99 from both sides. 0 pairs. 102 minus 99 is 3. Bring down my equal sign, and then what I'm left with, this is important, is I have opposite x. So opposite x is equal to 3. And I can substitute that in, and so 99 minus, look, it doesn't work. And the reason it doesn't work, we talked about this a little bit in class, just very briefly, but the reason it doesn't work is I am not allowed to have an opposite x. Because when I substitute that in, it doesn't really work. Now, when I have an opposite x, and so I'll just draw it here. So as an algebra tile, if I have an opposite x, how do I make that be a regular x? Or if I have a negative x, how do I make that become a positive x? And as we talked about in class with the algebra tile, what you do is you flip it over. So it was negative. Once I flip it over, now it becomes positive. And so anytime that we have a negative x or an opposite any variable, you flip it over. Not only do you flip that, you flip everything over. So I'm going to flip over my opposite x, and that becomes x. I'm also going to flip over my positive 3. That becomes a negative 3. And as silly as it sounds, what we talked about in class is I have to flip my sign. So I flip my equal sign. And so there it goes. Now my equal sign is flipped. Now x is equal to negative 3. Now I can substitute negative 3. 99 minus negative 3. Well, when you subtract a negative, you plus it, right? 99 plus 3 is 102. So that does check out. There is my final answer. So I'm not allowed to have an opposite x. And if I do, or an opposite any variable, you just flip everything over, and there it works. And so don't forget to flip your sign there, or your equals symbol. You have to flip that as well. Now, why is that important? And here's why. When I have inequality symbols, 25 is less than or equal to 15 minus x. My goal is to solve. I solve by isolating the variable. Variable is x, and with my variable is a 15. Now, it is important to note that this is a positive 15. How do I undo a positive 15? Well, by subtracting 15 or a negative 15. I have to do that on both sides. Creates a zero pair. Please do not forget about this guy here. That leaves me with opposite x. Bring my symbol down. 25 minus 15 will give me 10. But I'm not allowed to have an opposite x. So you flip it, but you flip everything. So I flip my x. Now it's a regular x, right? So it was opposite. I flipped it over. Now it's regular. I flip my 10. Now my 10 becomes a negative 10. And here is where it's important. This is that, that aha moment. I have to flip my symbol. So instead of less than or equal to, it actually becomes greater than or equal to. So I have to flip everything. And that will give me my final answer. I can substitute that in. 15 minus a negative 10. All right, that becomes plus. 15 plus 10 is 25. Yes, that works. So it is important to know that we have to flip everything. So when I flip everything, my symbol also flips. So it seemed kind of silly flipping my equal sign, but when I get in the habit of flipping everything, then I'm going to flip it also, right? So what I'm hoping is that something silly like flipping an equal sign will stick in your memory, and then you'll remember to do it when you have an inequality sign. So that's kind of my goal. All right. Opposite 9 or negative 9 is less than opposite of x over 3. And so here's what we're going to do. Is my goal is to solve. I solve by isolating the variable. My variable is x. With it is a 3 by way of division. So I undo divide by 3. I undo that with a multiply by 3. I need to multiply by 3 on both sides. Put that 3 over 1. That gives me, I'm going to basically cross cancel, gets rid of that. That leaves me with my opposite x. Please don't forget that. Opposite x. Bring down my symbol. And then 9 times 3 is 27. Positive times a negative is a negative, so that's negative 27. Now I'm not allowed to have a negative x or an opposite x, so I'm going to flip everything. Flip the x, flip my sign, and flip my 27. And my final answer is 27 is greater than x, or if you want, you can rewrite it with x, but remember, alligator, right, or whatever it is, Pac-Man, or whatever that guy is, eats the bigger number. So if I'm going to put my x first and my 27, I still have to eat the 27. So 27 is greater than x, or x is less than 27. Your choice. Those are the same thing, but there you go. That's my solution for this inequality. I hope this helps, and please ask questions in class so that way we can make sure you have a full understanding of this. See you in class.